Bismillahirrahmanirrahim. I am Sohail Bashir with my group member Muhammad Usman. We are going to let you know about polymers. We will discuss here the history of polymers, how they are formed. Now the history of polymers. Polymers were discovered long before anyone understood what they were. It wasn't until 1920 that German chemist Hermann Schrödinger made his molecular hypothesis. Suggesting that polymers are actually giant molecules formed by permanent attachment of countless smaller molecules. Through careful experiments, he proved his hypothesis to be correct and was rewarded with the 1953 Nobel Prize in Chemistry. Now the introduction. Polymers are long-chain giant organic molecules that are assembled from many smaller molecules called monomers. Polymers consist of many repeating monomer units in long chain. A polymer is analogous to a necklace made from many small beads. These beads are monomers. Another common name for many synthetic polymer is plastic, which comes from Greek word plastikos, suitable for molding or shaping. Many objects in daily use, from packing, wrapping, and build materials, include half of all polymers synthesized. Other uses include textile, TVs, CDs, automobiles, and many other. All are made from polymers. Now, polymers building blocks are hydrogen, carbon, oxygen, nitrogen, fluorine, silicon, sulfur, and chlorine. Types of organic molecules. There are two types of including synthetic and natural polymers. Biopolymers are natural polymers which include lipids, protein, nucleic acid, and carbohydrates, etc. Synthetic polymer is second type of organic micromolecules. These include plastic, synthetic fibers, rubber, etc. Now the classification of polymers. Homopolymer Homopolymer consists of chain with identical bonding linkage to each monomer unit. This usually implies that polymer is made from all identical monomer molecules. These may be represented as shown. The second one is copolymer that consists of chain with two or more linkage, usually implying two different type of monomer units. These may be represented as shown. A and B types of polymers. There are different types of polymers: homopolymer, copolymer, terpolymer, block, and graft polymer. These are shown here. A, B, and C are monomers. Classification based upon the physical properties related to heating. There are two types of polymers: thermoplastics and thermosets. Thermoplastics, in which that are softened when heated and become firm again when cooled. This is more popular type of plastic because the heating and cooling may be repeated. Examples include polyvinyl chloride and polystyrene, polymethyl methacrylate, and polystyrene. Thermosets, in which plastics that soften when heated and can be molded but harden permanently until they will decompose when reheated. An example is backlight, which is used in toasters, handles for pots and pans, dishes, electrical outlets, and billiard balls. Examples include epoxies, phenolic, and polyester resin. Polymers are further classified by the reaction mode of polymerization. These include addition polymerization and condensation polymerization. In addition polymerization, it is free radical addition reaction. The monomer molecule bond to each other without the loss of any other molecule. Alkene monomers are biggest group of polymer in this class. In condensation polymerization, usually two different monomers combine with the loss of a small molecule, usually water. Polyesters and polyamides are in the class of polymer this condensation polymers. Basic steps in addition polymerization. There are three steps: initiation, in which formation of free radical is formed; propagation, in which combining of monomers to form chain; termination, elimination of this is elimination of free radicals. In addition polymerization, the here it is a reaction in which ethene is converted into polyethene under high pressure and traces of CO2 and with catalyst. This is addition polymerization. Now I will call the next member Muhammad Usman to proceed further.
Thank you, Sohail. I will explain the condensation polymers. It involves two monomers that have different functional groups. They also involve the elimination of water or another small molecule. Hence the term condensation polymer. The monomer A plus monomer B forms a polymer with the elimination of small molecule, normally water. Common condensation polymers include polyesters and polyamides. This shows the condensation reaction in which phenol plus formaldehyde form the phenol formaldehyde plus water. In the second reaction, polycarbonate is formed with the hydrogen chloride. Polyesters. The OCR example here is pterylene, a polymer of benzene 1,4-dicarboxylic acid and ethane 1,2-diol. The ester linkage is found between the monomers. You need to be able to reproduce the formation of the pterylene and possibly predict the structures of the other polyesters. Polyamides. These involve the linkage of the two monomers through the amide linkage as in proteins, for example silk. This shows the amide linkage. Polyamide resins nylon 6,6 structure is shown in which 1,6-diaminohexane plus hexadioic acid form the part of nylon polymer chain. This reaction shows the part of the Kevlar polymer chain. Uses of the polyamides. The main use of polyesters and polyamides is as fibers in clothing. Most clothing now has a degree of manufactured fibers woven into the natural material such as cotton. This gives the material more desirable characteristics such as stretchiness and better washability. Don't forget that proteins are also polyamides. You must know how the linkage works with the natural polymers such as proteins. This shows the isomerism of the polymer in which three isomers are shown. One is isotactic, second is syndioatactic, and third is random. And now there are mechanical properties of the polymers. First is tensile strength. The tensile strength of a material quantifies how much stress the material will endure before suffering permanent deformation. In general, tensile strength increases with polymer chain length and cross-linking of polymer chains. Second is the Young's modulus of elasticity. Young's modulus quantifies the elasticity of the polymer. It defined for small strains all as the ratio rate of the change of stress to the strain. Like tensile strength, this is highly relevant to in polymer applications involving the physical properties of polymers such as rubber bands. The modulus is strongly dependent on temperature. Now there are the physical properties of the polymers. The physical properties of a polymer such as strength, flexibility depend upon the factors. First is the chain length. In general, the longer the chain, the stronger the polymer. Second is the side groups. Polar side groups give stronger attraction between polymer chains, making the polymer stronger. Third is the cross-linking. If polymer chains are linked together extensively by covalent bonds, the polymer is harder and more difficult to melt. Fourth is the branching. Straight unbranched chains can pack together more closely than highly branched chains, giving polymers that are more crystalline and therefore stronger. Now the disposal of the polymers. Most plastics are not degradable because decomposer organisms do not have enzymes to break them down. There are two important categories. First is biopolymers. These are polymers made by living organisms which decomposes. Polymers which break down naturally. First is photodegradable plastics break down in sunlight. Second is synthetic biodegradable plastics that are broken down by bacteria. Third one is the dissolving plastics which dissolves in water. It is possible to recycle some plastics. It is necessary first to separate the plastics into the different types. It is not yet economical to recycle mixed plastics from domestic waste, although some plastics recycling schemes are now in operation. There are the application of the polymers. First in the plastics, second is in adhesive, in films, fibers and elastomers. Thanks.